Today we arrive on our last lesson on naming ionic compounds. The last thing we're going to add is we're going to put polyatomic ions in our compounds. And this makes the naming rules just slightly different. But really, if you understand the naming rules so far, and you know your polyatomic ions, it doesn't add too much. And if you don't know those yet, that's okay. And we'll work on getting those down in this lesson. First, how do you know if you have a polyatomic ion? Well, when you're going from formula to name, and that's what our first few examples will be doing, going from the formula like AlPO4 to a name, then if you see that you have more than two elements, you know you have a polyatomic ion. So in AlPO4, we see Al, we see phosphorus, and we see oxygen. That's three elements. And our ionic compounds only ever have two ions, and that means we have one that's a polyatomic ion, that's more than one atom, but one ion. And that's, of course, our PO4 right here. And so that altogether makes our anion, that's negative, and our aluminum up here is a metal that makes our cation. So if you notice that you have an ionic compound with more than two elements, then you know, hey, I have a polyatomic ion, and be on the lookout for those naming problems. Okay, let's go ahead and name AlPO4. Now, here's the steps. First, you're going to write the name of the metal. That's just like our naming before. And then you're going to decide if you need Roman numerals. If yes, you're going to have to determine the charge. Then, lastly, we're going to write the name of the polyatomic ion. So really, the name is just three parts. Name of the metal, Roman numeral if needed, and then the name of the polyatomic ion. So here we have Al. That metal is aluminum. So we're going to write aluminum. All right, do I need Roman numerals? Well, remember, the rule here is if you can predict the charge, you don't need it. And if you can't predict the charge, you do need them. So what we want to do is go to the periodic table and see, can I predict the charge on aluminum? When we go to the periodic table, we notice that aluminum is element 13. And remember, this whole column here has a +3 charge. And so that means I can predict the charge on aluminum, so I don't need Roman numerals. Where I'm going to need Roman numerals is when I'm in this big D block area, or say in this column right here where I don't know the charge. Then when I don't know the charge, I'm going to need Roman numerals. And remember what those indicate. They indicate the charge on the cation. And that's why this rule makes sense. If I know the charge on the cation just because of its position on the periodic table, then I don't need Roman numerals. But if the periodic table doesn't tell me the charge, then I am going to need Roman numerals to indicate that. Okay, let's go back to our aluminum. And remember, we don't need Roman numerals because we know the charge is +3. Okay, when I come back, I got aluminum and I don't need Roman numerals. All I have to do is write the name of my polyatomic ion. So if I remember that name is phosphate, then that's pretty straightforward. I just add phosphate. And then I'm done. That's it. Okay, say you don't remember it's phosphate. Well, if you're working some practice problems and you don't yet know your polyatomic ions, then go ahead and just pull up the reference sheet that we have in these lessons and take a look, and that will tell you the name of all the polyatomic ions. But make it your goal through the course of the semester to memorize these and their charge. Okay, let's do another example. Here we have FeNO3. And then there's 3 of those. That's what those parentheses mean. Notice again, we have more than 2 atoms. And so we know, hey, we have a polyatomic ion. We need to write the name of the metal, Fe. By the way, if you don't know the name of Fe, you can go look that up on a periodic table. And you'll see right below Fe is written iron. And now we need to decide, do we need Roman numerals? So let's go to the periodic table and see. If we can't predict the charge, we need no Roman numerals. Okay, here we see iron is element number 26. Okay, I can't predict the charge. The charge, I don't know from the periodic table. What is it? And that means I need to use Roman numerals to indicate that charge to somebody else who comes along and sees this compound. So now we have to figure that out. This is probably the most challenging step for these naming problems, is figuring out that charge. Here's a good way to do it. Write a line for your anions and write a line for your cations. All right. Put your cations and anions in a stack. So here I have one cation, that's iron, so I'm going to put Fe right there. And I have 3 anions. Notice this 3 is telling me I have 3 whole nitrates. So I'm going to put 3 nitrates there. 1, 2, 3. Okay? Now I'm going to add the charge, and each one of those nitrates is a -1. And so that adds to -3. That means my total positive charge has to be +3. Since I have just one iron, that means my individual iron must be +3. So that gives me a neutral ionic compound. So that's what I'm taking advantage of there to figure out the charge on the cation. If you go back a few lessons, we did this as its own standalone lesson. So you can check that out if you feel like you need to review this process. So we know the charge is +3 on iron. And so that means that we have a 1, 2, 3 charge. All right, so we've written the Roman numeral. Now all we have to do is write the name of the polyatomic ion. NO3 is nitrate. So I write nitrate. Okay, let's look at another problem. Here we have nickel 3 carbonate, and now we're going the opposite direction. We're going from the name to our formula. Okay, so now we have the name and we're going to the formula. This is actually the easier direction. So what are the steps? First, we just need to write down each ion with its charge, and then we cross over to make our charge neutral. We got to use parentheses if we have multiple polyatomic ions. And lastly, we're just going to reduce those numbers if necessary. And we'll take a look at an example where you have to do that. So we have nickel, that's Ni. And this 3 tells me the charge on nickel is 3+. So remember, those Roman numerals tell you the charge on your cation. Then carbonate, I just have to remember that that's CO3 2-. That's just what carbonate is, and that's just memorization. Okay, now I cross over to get a neutral compound, which means my 3 is going to come down here, and my 2 is going to come down there. Now I'm going to rewrite my compound with those numbers, and that's telling me that I have 2 nickels, and I have 3 carbonates. Now, since I have multiple polyatomic ions, here's where I got to use parentheses, 3. Now, why did we have to do that? Well, remember, our ionic compounds are always neutral. And so now I have 2 things at +3 for a total of +6. And I have 3 things at -2 for a total of -6. So +6 and -6 cancel out. Last thing I can check is, can I reduce 2 and 3? Is there any number I can divide 2 and 3 by? That'll give me 2 new whole numbers. And the answer is no. I just stuck at 2 and 3. And so that's my final answer. So there we have it. Ni2 and then 3 of our CO3s. All right, let's do another one. Here we have copper 2 sulfate. Okay, so write down the charge of each ion. That's Cu2+. Again, the Roman numeral tells me the charge on the cation. And then I write down sulfate, which is SO4 2-. Now I'm going to cross over 2 and 2. So the 2 goes over here and this 2 goes over there. And then I'm going to get Cu2. And I have 2 polyatomic ions, which are both sulfate. So I'm going to put parentheses and then a 2. Now notice these 2's can be reduced. In fact, you might have noticed at the beginning, I had a 2+ and a 2- with my copper and my sulfate. So that was already neutral. And in fact, I can reduce this by dividing both sides by 2 and get my final compound, which is going to be just CuSO4. And maybe you saw that already after we just wrote down the charges. And if you did, that's great. And you can just skip right to writing that. Okay, one last example. Magnesium dichromate. Again, I'm going to write the charge on each ion, which is Mg2+. And then I'm going to write down what dichromate is, which is just Cr2O7. And the charge is 2-. Now, I could once again cross over, but you might be able to see right away that the magnesium has a 2+ and the dichromate has a 2-, and so those are going to be perfectly balanced already. So if we crossed over, we'd get 2 of both, and then we'd reduce it back to 1 of both. And so we'll just go ahead and write our final compound, which is 1 magnesium and 1 dichromate. So it looks like MgCr2O7. Okay, that's how we name ionic compounds with polyatomic ions. Hey, hey.